with us about quant trading, so let us give him a big hand.
So there are a lot of people talking about quant trading and AI nowadays, and when you go on Google and you search quant trading, artificial intelligence, you can find a lot of blog posts saying about, oh, I got a strategy that really works. I applied LSTM, RNN on all my data set and it worked. And they actually, and when I looked into that code, and there are actually a lot of assumptions that doesn't really make sense, but they don't realize they have made those assumptions. So today, instead of giving a lot of implementation stuff, I'd like to talk more about the practical approach in terms of applying AI into quant trading, as well as the common pitfalls you will face when you're trying to do so. So the purpose of the talk today is really to foster more discussion in terms of the intelligent use of AI in trading, and more importantly, to use AI to enhance the trading visibility of the reality. And three things I'd like you to take away from this talk. First one, I hope you can develop your own trading strategy with Python. First one. Second one, when you're trying to implement your own strategy with Python, there are some kind of pitfalls that you would like to avoid, and I'd like you to be aware of that. And thirdly, I'd like to talk about what are the challenges right now facing in trading and AI, and challenges means opportunity, and what are the opportunities that comes in this industry. So process. When you're doing any kind of R&D, we talk about process first before diving into it. So there are 5 major steps when you're doing analysis in quant trading. The first one, data curation. So for data curation, it really means the collection of data, storing the data, and also adjusting the data. So what do I mean by adjusting the data? So you really have to understand what the data means. So for example, for stock data, you don't just take all the data, price data in. What you have to do is that you know that stock, they have stock splits, they have dividends. You have to adjust these kind of factors before you're storing into your database. For example, for futures, there are rollover. If you're doing rollover, you have to handle rollover situations in terms of before storing all those prices into the database. And second, feature analysis. Feature analysis are all those fancy AI stuff. So some people use a lot of AI algorithms, some people use correlation, all those different kind of things. Those are black box. Those computers doesn't understand why they have such kind of pattern exist in the data. But there they go. There is some pattern. So people would stop at this stage and then immediately go to implementing the solution and then trade it. And they will find that it won't succeed. The reason why is that they ignore the third part, which is the strategy. Strategy, a lot of people mix up strategy and feature analysis. Strategy is white box, meaning that when you see a lot of patterns in the data, how do you explain them in real life? For example, if you find that, for example, weather has an inverse correlation with the natural gas prices, for example, you find that through the computer science correlation stuff. But you really have to explain it in the real world. Why does that have such kind of correlation? Which is leading to which? Instead of it's A leading to B instead of B leading to A. And the fourth one is the backtesting. So when you find an opportunity, when you're really putting it into production, there are some kind of like trade commissions. There are a lot of you're putting limit orders. You are putting some different kind of stop profit stuff. If you put those into place, are they going to work? Is your strategy able to capture all those opportunities? That's the backtesting. And finally, deployment. So there are 5 steps in general, and I've simplified it into three things, which is the data, the first part. The second part is the function that maps the data into the alpha, which is the opportunity. People call it alpha. And afterwards, if you've got a lot of different kinds of opportunity, how you can actually gather all these opportunity and make the correct decisions is the portfolio management. So 3 parts that you need to care about. So I'll talk about that one by one. For data, wait a little second. So for data, there are a lot of different kinds of data in the world. And for those that matters finance the most, I've categorized it into 5 different categories. So you can have macro data, which means the global data, economy, industry data that doesn't affect a particular asset or company. And you have fundamentals, which talks about the financials, all those things that is released like semi-annually, annually, etc. And you have the market data that is the financial assets that is built on top of the asset. For example, stocks, debts, commodities futures, for example. These are traded every day, every minute, every second. And these are all the market data you would like to get. So, and for the right-hand side, you see events and alternative data. These are the data that can provide predictive analytics towards all these data on the left. And there are functions. So there are functions. So for the functions, I mainly would focus on AI functions today. So there are, and you can see that for machine learning, it's mostly on the prediction, pattern recognition within all these data. So these are the black box things. So we talk about the feature analysis. So this is the feature analysis part. And for the NLP and speech recognition, it's more like a data curation. So for example, when you're reading a news, how you can extract important information from the news that you can store inside your database. You don't want to store all the news, all the words inside the database because there are so many noises and it's not useful for you to store it. So you need to what you need to do is extract the information that is valuable to your database. So that is the data curation part for both the NLP and speech recognition. And for the right-hand side, which a lot of people, very few people talk about, is the knowledge engineering. This is the white box. This is the strategy I'm talking about. A lot of people would rely on people like human, or actually forget to rely on human for this. But actually, it could be implemented with the domain knowledge. So what you really need to do is to cooperate with the domain experts to have some kind of like building. There are some kind of AI algorithms for that. For example, the Bayesian learning, Markov, which are part of the PGM, for example. And the third part is the portfolio management. So in trading, a lot of people only focus on the timing. They analyze when to buy and when to sell, but that's actually more than that. There are 2 more parameters you need to care about. The first one is the asset picking. What kind of asset you're picking? So that could be trained as well. And also the position picking. How many bets are you going to put on your position? Are you putting a positive, how much by how much, and negative shorting by how much, for example? And the function part, the AI part that I talked about, focus on the asset and timing picking. And for the portfolio management, it's the position picking. And you can imagine when you have so many opportunities that come to the portfolio management part. And for example, every opportunity they are saying that buy Bitcoin, buy Bitcoin, buy Bitcoin. And are you going to put all your assets towards Bitcoin? Definitely not. So portfolio management is really to manage your risk of your portfolio to avoid yourself being broke. So there's a recent news. If you read the news, it's just a few days ago. This guy managed around $200 million of options, and he recently go broke because he do a naked short on the natural gas position, and the natural gas position just go up by a little, and then he lose all the $200 million. So this is risk management or portfolio management is really, really important. So today I'm not going to talk very, very complicated things, but I'd like you to get the logic behind how the process of devising a strategy is. So focus on the logic, but not focusing too much on the implementation. So this is an example I'd like to raise. Some people would always say, oh, I think the market is going down. How could I actually trade? So there are some kind of straight trading strategy which is called the long short. You don't care about the market. So even the market is going down, if you know about the ranking of stocks, one is going to outperform another, you can make money from it. So in this case, because a lot of people are talking about 2020, the market is likely to have a great depression, so I'd like to talk about this. How do you implement a long shot, for example? So in this case, I don't use very, very fancy data. I just use open, high, low, close pricing data, volume data on Google and Apple. I rank these two stocks, and they belong to the same industry. And the first step, I call the library that is relevant NumPy, Pandas, Scikit-learn. Scikit-learn is the machine learning algorithm library. And step 2, I read the data from my CSV file. I read around 2014 to 2018, roughly 1,000 samples daily. And third, I calculate the return and normalize the data. Normalizing is very important for any kind of AI strategies, because for different kind of features, they may be in different orders. Some of them in order of 10 to the power 1, some of them in order of 10 to the power 3. If you do not normalize it, you may be overweighting on some of the parameters. So for step 4, you prepare the target data. So now you're trying to rank between Google and Apple stock. So if Google returns larger than Apple, you put it as 1, else you put it as 0, and then you separate training sets and the training sets and test sets. You don't want all your data to go into the training, because that would probably overfit your model, and you don't know how it will actually perform on data that it has never seen before. So split it, and then apply logistic regression and calculate accuracy. And finally, the return is not really good. 44% accuracy is even worse than 50% accuracy. Why is that? Because I didn't put in my domain knowledge. I just put in rubbish in it, and then rubbish in, rubbish out. You're trying to put some rubbish in the AI algorithm, and it won't work. So I'm not satisfied with it. So what I'm going to do, my logic is that a lot of people at this step would focus on, okay, I'll just build more complex AI algorithm. I'll do neural networks, I'll do LSTM, I'll put more layers on it, and it doesn't work. It would just create more bias because the data sample is so small with 1,000 samples only. So what you really have to do is to change the data, use your knowledge to change your data. So my hypothesis, for example, first, I think that OHLC data is kind of similar. So I gather them all together to make a new data called OHLC divided by 4. Because it's not really useful to have 4 different kinds of features, I just put it as 1. And for example, I care about the accumulated return that people get, because some people would exit at 50%, some people would exit at negative 50% to stop loss. There are different kind of stop loss, stop gain, etc. So what I'm trying to capture is the return that they are getting, average return over a period of time. So I use some kind of average return over a period of time and volume weighted by it. And then I put it into the model again, and it generates 65% accuracy, which is okay, but what I'm targeting is actually more, like 70% would be really great to go, 75% even better. So what we can do more is the story behind this supervised learning is that you are not trying, when you face a difficulty in this situation, don't try to go for very, very complex AI algorithm. What you're trying to do is that do more feature engineering. Do more feature engineering with your knowledge. So another example is unsupervised learning. One example would be, I would like to see what kind of historical days would be like today. So how do you define similar? Similar is like there are a lot of features, like for example momentum, there are liquidity, there are volatility, there are many different kinds of features you can look at. So, and also when you have very, very high dimensional data, how do you measure the similarity? That's the problem statement of this situation. So what I'm trying to get is, I do a lot of technical analysis. I just focus on open, high, low, close as well. I didn't put out all the codes here, but I have created all these kind of functions here. This gives me around 20 different kinds of features. And then afterwards, after I have a list of different kind of features, it will look something like this. So for the column side, it represents different kinds of features. For the row, it means different dates. One row means 1 day in the past. I have around 1,000 samples in here. So what I'm trying to do is I normalize the data, same as supervised learning, and then I apply the SVD. SVD is the compression method that compress high dimensional data to low dimensional data. Here I have 20 features, I compress it into 10 different kind of features. So how does SVD works is you can imagine yourself on a 2D plane. You have a lot of points on the 2D plane, which kind of simulates a straight line. Straight line, you can pass through it. It's like the regression problem. And previously, you're trying to represent the coordinates with x, y, x and y, 2D, right? How do you turn it into 1D? If you plot a line, you just store the direction of the vector, and all the points would be on that line. You assume that all the points will be on that line. And you represent those points by the weights, a multiple of that kind of vector. So you can turn 2D into into weights, which is 1D. So that is the similar concept in SVD. I turn 20D data into 10D data, and the information that is contained is more than like 99% still preserved inside the samples. And then later on, I apply t-SNE. t-SNE is turning high dimensional data into 2D representation, and the distance between the data represents the similarity between the data. And then I apply the clustering. Here I use the affinity propagation instead of the k-means, because I personally don't want to specify the number of clusters. And for affinity propagation, I can just allow it to find the number of clusters for me. And later on, I have something like this. So all the points here represent different kinds of days in the historical past. If I want to compare today with some day in the historical past, I can just find where is today lies in which kind of cluster. And then I can see all the points around that cluster that are similar to today. So you can see that from the previous two examples, the story behind is don't use very, very complex algorithm, because there is not enough data for that if you're using daily data. And focus on the data itself, focus on domain expert, focus on knowledge. That's the story behind. So some kind of useful Python library that you would use. NumPy, Pandas, Matplot library, those are simple. And scikit-learn, for those who are using machine learning a lot, this is good, but they don't have PGM. They don't have probabilistic graphical models, which I personally really like it. And also the TensorFlow. TensorFlow is optimized for the neural networks, and it's great for, it also works great on the Google's TPUs as well. And PGM-PY for PGM algorithm, I personally write it myself. And QuantDL, AlphaVantage are for free. Some of them are premium data. So pitfalls of using AI. So in terms of data curation, so biased data is the first #1 pitfall. So biased data, there are look-forward bias and survivorship bias. Look-forward bias meaning that you're taking future data to predict future data. That happens a lot. That happens a lot for the people who initially get into space. And survivorship bias, meaning that you're taking just the data you have today to predict the future. But remember, the data you get today is already has survived maybe 100 years already. Those are companies that have survived for 100 years. And you're ignoring companies that have died in the past. So for these two kinds of bias, you are overestimating the accuracy or the prediction ability of your algorithm. So if you see that your algorithm is performing like 80% or 90% without actually a lot of data massaging or data curation, then probably you have made one of those mistakes. And low quality data, throw out away too much data. I'll talk about it later on. And common curation steps. So for stock prices, you need to adjust for splits and dividends. Futures prices, adjust for rollover. FX prices, they are traded OTC, so volume data doesn't mean the volume all around the world. So time zones, holidays, those stuff. And one example I'd like to raise is the low quality of data, which a lot of people still made and professional traders made as well. So I'd like to put it here. For daily data, monthly data, quarterly data, yearly data, these data, you can see if you're taking daily data, 10 years, you have 260 trading days for each year. You have 2,600 points for your data set. Too few data points. If you have a very high dimensional space, then you're very likely to underfit your model. And for tick data, you can imagine if you're market open, when market opens and when market closes, there's most activity happening in the space. And if you're trying, and you can imagine in the middle part of the market, it's usually the quietest market. And if you're doing bar, for example, 1 minute bar, you're capturing too many bars for areas that have little activity, and you're storing too much information in one bar for activity that is high. So that is not accurate. So you have a lot of noise in the middle, a lot of text that is useless, and a lot of text that store too much value, and you're summarizing it too much. So the solution for that is, one solution is the turnover bar and volume bar. So for turnover bar, it's meaning that you're trying to get the volume into volume, for example, when volume or turnover exceed a certain amount, and then you put it as one bar. So when the market open or when the market closes, there are a lot of these kind of bars. When the market is in the quieter sessions, it will have less bars. So that is one idea. And another example is people generally throw away too much data. So a lot of people only focus on the return. When you have a price chart, people would just do a first order change of the data and then calculate the return from it. So the problem here is that they throw out one important information by doing so. It's the price. They throw away the price data. So in this situation, you can imagine when you are doing the first order derivative, you are calculating the return. If you are doing the zero order derivative, you are calculating the price itself. So if you don't want to throw away too much data, you can consider doing a fractional differentiation. Fractional differentiation meaning that you're not doing zero differentiation or one differentiation. You're doing a differentiation between 0 and 1. That is one technique in data creation as well, but a lot of people ignore that as well. Not many people use that. And the second part is the risk management. Risk management meaning one example is that neural networks or a lot of the AI algorithm forgets something that happens just once. They will put it very, very further back and then forget it. And they just focus on something that works consistently well. So, and a lot of AI cannot provide good predictions on network they have not encountered before. On scenarios that they have not encountered before. For example, I had a friend who told me that he had a very good Bitcoin strategy last year in 2017. And then I asked him, what's your strategy? He said he applied LSTM on the Bitcoin prices, and oh my God, it's generated huge returns. And the problem here is that Bitcoin prices has been going up until the late 2017. So at that time, I told him that you are training on data that is always going up. Have you trained on data that is going down? No, because there's no data. They have not encountered even, right? So I say, so you can imagine if you use this LSTM is not really robust because what I say I don't need LSTM. What I need is I just buy every second, then I will earn money. I don't need an LSTM, right? So that's the problem. Is that they don't have that kind of thinking. Is that to predict on scenarios that have not encountered before. So a solution one would be if some neural network forgets some kind of events, you can try solution one, which is LSTM, neural network with attention memory network, which stores information within the memory system, but they are in bits, which human cannot understand. So you can look for articles for that. I've read a lot in that. And solution 2 is the knowledge engineering and generalization, meaning that you're building domain knowledge into the system. And those systems are white box, meaning that you can trace and understand, unlike like neural networks, you can understand why the AI is making that kind of decision. And the third solution is a good risk management system. Why is that? It is complementary to the first and second solution, because first and second solution cannot provide a complete picture about the world. Sometimes something happens that is unexpected. You need a really good risk management system for that. So these are some reference for the LSTM neural network with attention and memory network. So challenges and opportunity. As I said, challenges means opportunity. So I have defined short-term focus and long-term focus, but they are actually all the current problems that we are facing in AI and trading right now. So the first one is we don't have enough structured data. There is a lot of data around. You can find on Google, you can find on a lot of Twitters, etc. But you didn't actually extract all the data or all the value from it. So one solution is turn unstructured data into structured data. That is one big part that you can do, which is easy, and you can use all those like NLP neural networks to do that. That is okay. And for problems, second problem is too much useless data. So you collect a lot of data, and then those data, a lot of them is actually useless. So you need to extract the value from those information, and that requires some kind of domain knowledge. You have to work with domain expert on that. And for long-term focus, I would say, because it's a little bit harder, so I put it as long-term. So making decisions based on incomplete information under uncertainty, meaning that it's unlike AlphaGo. AlphaGo has a confined board, confined game rules. It works very well. For example, you play on Atari, for example. They have confined things. They have all the game rules that govern the whole system. So it's a confined world, but in the financial world or the real world, there are so many factors that you cannot put all of them to the model. So it's different. It's a different problem. In the Go problem, it's a certain situation, but in the real world, we are making decisions based on uncertain information, and that is what Bayesian Markov works very well, and you can use those. And second is general AI algorithm cannot deal with causation, and that's the problem of general statistics as well. So what statistics can do is they know the correlation, but they don't know the causation. So causation is a very, very big part. That if I would recommend you to read the book by Julia Pearl. He's an expert in causation. So the method is same using AI, and and the final one is most popular AI are black box, and there's lack of white box strategy. So we really need the basic infrastructure. We have to work with the domain experts in order to make good data, good algorithms in the world of AI and trading. And that's all for my presentation today. And I would welcome any kind of questions.
You touched on the point about the bias and variance dilemma.
Correct.
And we are dealing with the time series data
Correct.
in the financial world. So what is your thought about the walk-forward strategy or other strategy that could overcome the overfitting in the financial data?
Okay, so one strategy that I mentioned before is that you're trying to extract value from it. For example, underfitting problem. You basically have too many features that you don't know they are really, I don't know whether they're really useful. So many of them are useless. And even within the time series itself, many timestamps, many data within the timestamps are useless. That's the problem in time series analysis. So one way I suggested is to use the turnover bars. Turnover bars meaning that you're trying to confine the activity for each bar to be the same. You're not storing too little data in each bar, which is noises basically. You are putting all those data into a compact compact bar which has certain kind of activity for each bar. That is one solution that I propose.
Sorry, one more question.
Yeah, sure.
In terms of defining the target and the label, some people think that predicting the price itself is very difficult because the price is volatile, right? Is there any way to capture like trend, or what is your recommendation to define the target in your classification algorithm?
Defining targets.
Or the label.
Labels. It really depends on the algorithm you are, or the target what you are trying to do. So so one thing I've mentioned before is that you're trying to, some of them are creating so for example, I previously trying to do unsupervised learning, right? What the unsupervised learning is doing there is that they're trying to create one more label, which I don't care about. I have a lot of features. I'm trying to condense them into 1D, right? 1D. So that is, I have a lot of features, high dimensional as well as you mentioned before, and I'm trying to condense it into 1D, which could be a label, potential label for that kind of tickets that exhibits some kind of similarities. Yeah.
For AI and trading, basically, a lot of the data sets is like shared in the public space. So if you use AI models, would you see it would exacerbate more models doing the same strategy, doing crowd, like we just go crowd somewhere, maybe the same asset class, or recognize the same patterns and just makes it more crowded? Do you see this problem?
In my opinion, a lot of the strategies that is general, that is using like the same model, are not going to work. The reason is it's like you are buying a Mark 6 ticket, for example. Will you tell your strategy to someone else? Okay, I'm buying this. I know I have a time machine that goes tomorrow, and I know the Mark 6 numbers. And are you going to share it to someone else? Because you know you won't. Because if you share it to someone else, someone is going to share your profit, right? So if there is really a strategy that works, and a lot of people are using that, and that strategy eventually doesn't work because everyone is chasing for that strategy. That's the first point. Second point, as I mentioned, if you're using general AI strategies right now, and it's highly unlikely, 99% that it's not going to work in long term.
So follow-up question on regarding a label. Here.
Yeah.
So when we make an investment decision, right? So we would think about not just the next day stock price or asset price going up or going down.
Correct.
We want to pick up some trend, right? So how would you apply what you mentioned just now to pick up some trend is coming up?
For the trends, it's more likely to be unsupervised learning. What you are trying to, it's more like pattern recognition, right? So you have so many time series for different kind of stock data. And what you're trying to do is pick up some trends that you think is happening over and over again, and you can relate it to technical analysis, right? So technical analysis are human. They identify some kind of patterns. Okay, so this pattern is working for the past number of years, right? So I'm using this pattern to trade, for example. And but the problem is, if you notice that for the past 10 years or 20 years, we are using technical analysis that lasts for have been using for 100 years ago, right? And for the current 10 to 20 years, no one is talking about, there are some, one or two new technical analysis, but there are no new ones because I guess no one is actually sharing it. So I think for AI, I think what we can really do is use unsupervised learning to identify some kind of patterns in the past, and I'm sure there are a lot.
Hi, hello. Hi. I have a question on the number of features. So you said the number of features are so not enough, just like 1,000 points over 10 years. So in your previous slide, you mentioned we can add some like technical indicators like MACDs
Correct.
and some
Yeah.
kind of summarization of the stock price to kind of add some more features. But is it really helpful to overlearn it? Because all the indicators they all derived from stock price. To me,
Correct.
the features is kind of outside stock price, some kind of information.
Okay. Yeah, that's what I want to say as well, because I say it's a very, very simple program that gives you a sense of what's going on. So first thing, you don't only use stock prices. That's the first thing that I mentioned. And the second thing is that there is more information you can imagine within the data. More information than you imagine within the data. Some people say, okay, time series price data is just one data. If I use MA, if I use other different kind of technical analysis, are they actually extracting the same thing? And they are not, because some of them are extracting momentum, for example, how fast it's going up. Some of them are extracting volatility, how volatile the stock is going. So they are extracting different kind of features from all the historical past data. And you can say they are actually extracting the same information. So there is still huge work to be done, but that requires, as I said, if you want to extract more values from it, you need more domain experts. You need to look at stock prices every day. So that's the first thing. And the second thing is that, yeah, you're right. Not only stock prices, there are a lot more data you should add in.
It is quite common that for different kind of fund has a really large positions, say 10% of a company. So is there anything from the angle of quant trading can assist this kind of large position? Because the problem is that if you have this large of position, when you buy, actually the price should be go up. It is very natural because you have, say, like 100 of days to liquidize your position. So is there anything you can help from the angle from quant trading?
I think it's a little bit harder because a lot of times when we are doing analysis, we assume that the environment won't change according to our actions. You understand, right? So a lot of people, when I'm talking about reinforcement learning, usually and the environment would give, you would receive, for example, you make an action to the environment and the environment would tell you, okay, when you make this action, the environment would actually change. But when you're training on the historical past data, you assume, you make a very naive assumption that the historical data won't change according to your action. But in the real world, it isn't. Even if you put a position inside the market right now, if you put a huge position in there, the market would change. Even a strategy that, if you're putting a huge one, of course, if you put it hidden, no one would notice, right? So I personally think that if you're dealing with large positions, and those strategies are usually focused on the fundamentals, driven by fundamentals, and they are driven by long-term ideas. So you don't really look at very, very small things. You look at large things, for example, the macro, for example, the industry. In that sense, I think that AI would need some further work, which requires knowledge engineering, more kind of knowledge engineering before we can reach that kind. But if you're talking about general AI, I don't think that it will work in the short term.
So is it more like you hint on that quant trading is still working on a very short time frame of horizon? Say you assume your position will be exit like a week or something?
I would say that quant trading, yes, if you are talking about quant trading in the very short term. If you're talking very long term, you require some more knowledge in terms of what's the market going on. For example, if you're talking about why would Apple suddenly go up by so high, right? Why would Apple go that way? Why would Bitcoin go that way, right? Why is Bitcoin going up and then going down suddenly? You have to understand, for example, for Bitcoin, if you're going up, why would the AI understand it's a bubble, right? Why would they understand it's a bubble? Because when they look at the historical past, they understand what are the, you need to talk to domain expert. What's a bubble, right? What's a bubble? What kind of features I need to extract in order to identify a bubble? And for a human, it's easy. I look at the prices. I compare it with the historical bubbles. That is the tech bubble. That is the different kind of currency bubbles in the past. And you compare it, and you find that there are a lot of similarities in between. And I at that time when it's going up to like, it's crazy at that time. And then it's like 19K or 18K or 20K US dollar at that time for one Bitcoin, and then at that time I was right before a few months before that I would say it's not going to work in the long term, and immediately it crashed. But for AI right now, you cannot predict that, right? Yeah.
Thank you. Questions? So I'm not an expert with financial trading and stuff, right? So I'm just wondering, for example, we know like several months ago in the US, in the short-term trading, they have a market crash because I think like a lot of big players are using AI to do the stop loss, and everyone all programs just crash and make the market goes down, right? So for us, like the beginner in financial trading, do you have like any recommendation should we build our own AI or should we just trust it to some provider, for example?
I personally think that you should build your own AI. Don't use something that is very, very general, like those kind of like online stuff, like blog posts saying that it's going to work. Those kind of, as I said, there are a lot of bias within. The data has bias. The algorithm, when they use it, has bias. So it's better for you to actually read a lot of books, read a lot of financial books, understand the financial market, or find someone who understands the financial market and talk with them. Build that knowledge within your model yourself, and that would generate a lot more value. Because value is always, I would say, if more people find it, and they will extract it, you won't get it. People say there's no cash on the table, meaning that if it's something that is easy, if that's something that's online, if that's something that's so easy you can build it, find it online, then it's not something that you're going to go for. You need to go for something that is very niche yourself.
Do we have a last question?
I'm sorry, one more question. You mentioned that the trader should spend more time on feature engineering. Right?
Correct.
And so when do you see that they should consider the TensorFlow or the neural network versus the more shallow learning like XGBoost? When do you see the neural network add value in the consideration?
Yeah. So as I said, there are a lot of challenges. I can go back to the previous slide. Okay. So for the neural networks, those stuff, I would say if you're turning some unstructured data to structured data, that would be where you can try using those neural networks yourself. Because a lot of times when you're making decisions, when you're making trading decisions, you need to have an understanding why you're making those decisions. But that is not, current AI or neural network cannot do well on those cases. What neural network can do well is something that human could not explain very well. But human can do it very well. For example, if you do facial recognition, if you're trying to extract important information from a news, for example, those things are something that neural networks can do, and people trust that because you don't need to explain why I can recognize you because of your eyes, because of your hair. You don't need to explain to me because everybody can recognize it, right? So that's where neural network can do very well on trading right now.
Thank you.
Okay, so let us thank our speaker again.